So friends, now we will discuss the time dependent equation or the derivation of time dependent Schrodinger equation. So here, as we know that we have a general three-dimensional equation, del square psi is 1 upon u square, del square psi upon del t square. This is the general three-dimensional wave equation in physics, and the solution of this equation will contain the psi xy z t term and a function phi xyz and e to the power minus iota omega t. In the derivation of time independent equation, we have differentiated this for 2 times, and here we will differentiate for once. So del psi upon del t, we can write minus iota omega phi xyz e to the power minus iota omega t. So it is minus iota omega, we can write psi, and we have omega is equal to 2 pi nu. So del psi upon del t, I can write minus iota, in place omega I can write 2 pi nu psi, and E is equal to h nu from the Planck's relation. So nu is equal to E by h. So we can write del psi upon del t is equal to minus iota 2 pi, in place of nu we can write E by h minus iota, this h upon 2 pi again is h cross, h upon 2 pi is equal to h cross. So I can write minus iota E by h cross. Now if minus iota E by h cross, if I multiply iota and divide by iota, a minus sign is already there. So this iota will be minus and this minus will be plus. This iota will be minus and this minus will be plus. So we can write it del psi upon del t is equal to E upon iota h cross, or iota h cross del psi upon del t is equals to E. So the value of E, we have calculated iota h cross del psi upon del t from this derivation. Now earlier we have derived Schrodinger's time independent equation, and that was del square psi plus 2m h cross square E minus v psi is equals to 0. So this equation we can write del square psi is equal to minus 2m h cross square E minus v psi, or minus h cross square 2m del square psi is equals to E minus v psi, or minus h cross square upon 2m del square plus v psi is equals to E psi. So here this psi is there in all these functions, psi is there in the previous psi and psi, E psi. So from the previous derivation E psi, we have iota h cross del psi upon del t. So if I substitute the value here, so it is minus h cross square 2m del square plus v psi is equal to iota h cross del psi upon del t. Then this equation is known as Schrodinger time dependent equation. So what in this equation basically represent that minus h cross square 2m del square plus v, one term is this, and iota h cross del psi upon del t, one more term is this. So this basically represents the energy E, and this we write as H, Hamiltonian. So if again I write this minus h cross square upon 2m del square plus v psi is equal to E psi. So what is E? Total energy of the system. What is V? The potential energy of the system. So this term represents kinetic energy. So Schrodinger time dependent equation, what we can say, that it is the energy equation, that it is sum of kinetic energy plus potential energy equal to the total energy. So Schrodinger equation is nothing but it is a energy equation in which sum of kinetic energy plus potential energy is equal to the total energy. So if I write minus h cross square 2m del square plus v as Hamiltonian, so we can write in short form h psi is equals to E psi, and it is the short form of the equation that is known as Schrodinger time dependent equation. Now in these equation, whether it is time dependent or independent, what this psi represents, it is the important point. So physical representation of psi, the wave function. So according to Schrodinger, initially, that according to Schrodinger, this psi, it was particle amplitude and psi square as particle density, because the equation, Schrodinger equation, is written for particle. So in the analogy of optical waves, that psi square, it was represented as particle density and psi as particle amplitude. In optical waves, what happens, that the optical waves are written for photons, and in these equations, optical waves equation, this A is proportional to amplitude and A square is proportional to the intensity, and here the intensity of photons and intensity of amplitude. So optical waves are written for photon, so in here A represents the photon amplitude and A square represents the photon intensity, and Schrodinger equation is written for particle, so psi will be the particle amplitude and psi square will be the particle density, because the square is intensity or density in the analogy of optical waves. Now we can have here that amplitude is suppose A, then A is proportional to amplitude. We are correlating that how this A square is intensity and here psi square is particle density. So these two we are correlating. So A square is proportional to the intensity. Intensity means number of photons per unit volume into energy of one photon. That is A square is proportional to n h nu upon volume. H, where n is number of photons, n is number of photons. So A square is proportional to, if h nu I divide here, then it is n upon number of photons per unit volume. A square upon h nu is a constant, the energy of a one photon, so I can write it as A square, and number of photons, it is photon density. So A square represents photon density in optical waves, number of photons per unit volume. So same way psi square will represent particle density, because this equation is written for particle, and A is proportional to amplitude of photons, amplitude. But this concept of physical interpretation of psi, this Dirac, Heisenberg, these are the scientists, Heisenberg, they have objected that we cannot locate exactly the position of particle, then how we can talk about the particle density, because in this in the concept of wave packet, what we say, that we can have the probability that here at where the amplitude is 0, the probability of finding the particle is 0, and when the amplitude is maximum, the probability of finding the particle is maximum. So what we can say, that we cannot exactly locate the position of particle, we can calculate only the probability. So nowadays this psi square is known as probability density and psi is known as probability amplitude. If we call probability density, particle density, then exactly we have located the particle, but we cannot locate exactly the particle, hence we will call only the probability density. So psi square is known as probability density and psi is known as probability amplitude, and it is the physical interpretation of psi we can have from the analogy of optical waves in this way.